The title of this talk is Transport and Service Separation Conflict Resolution in Intent-Based Services. And that's quite a long title, right? And I imagine some of you would think, what is this even about? It's not very clear. So yeah, it's really a little bit of a bad title. And I'm going to speak today about how I think network automation peaked in 2006, how I prefer to do my services in NSO, and some of the experiences and problems I faced with our intent-based service designs and solutions to that. My name is Alan Ising, and I work for Telia Company. I work in Norway, but Telia is a Nordic and Baltics-oriented service provider, and I work with automation as an architect and developer. I live in Norway, but I'm originally from Denmark, where I've been part of founding something called DKNOG, which is an association by network engineers for network engineers, where we have a conference once a year, where we invite everybody who works with network engineering in one way or another from all the Nordic countries and any other country to participate. And I've been part of founding this organization, and I've been driving it for many years. And I would really like to encourage you, if you're a network engineer in the Nordics, to come by and see what we are doing here. And because we are at a Developer Days conference, I think it's very fair to start with an old classics, my automation journey. Because my automation journey starts in 2006, and as you may remember, this is where automation peaked, right? Because in 2006, I was still in university, and I worked part-time in a call center for a small residential ISP. And this residential ISP had a network automation, and it usually worked. And sometimes it didn't work, it was very rare, but when it didn't work, it was my job to re-provision the customers. And that happened with a button that says provision. And I clicked it, and it worked. So from my perspective, in 2006, I found network automation to be very easy. Fast forward, not very long, because I worked at a call center, and that's not a very good place to work, and I finally land a proper job in the industry. I start in a NOC, as many people do in this industry. And this is a more classic telco experience. So if you remember, or were there at the talk yesterday about the various levels of automation, we are at level -1 here. All the automation happens by logging into the equipment. This could be a router you telnet to, because you telnet back in those days. And you type in the commands to configure the circuit. You don't even paste in a template, because it might not be one. Otherwise, you log into an element management system, click around, and do whatever you do in an element management system. And the difference, of course, is quite fundamental. I started out as a residential ISP, built for scales to the millions. So automation is kind of fundamental here. In the telco business and operator industry, well, we built with different scales, and it was a small company, and many technologies. Automation was not on the radar at all. Fast forward a couple of years, I get out of the other job just before they went bankrupt, and I started a small company that built automation from the beginning. Level 1, of course. So these are scripts you have to run in the right order, with the right parameters, and it will activate stuff in the network. No real intelligence, but it does the job. And we have people who are not technical experts run these scripts with great success. In 2011, I continued back to my roots in the service provider industry, and I again work in a business context with a proper network, with an access network, and we develop zero-touch deployment systems. But other than that, we have a whole department employed to just sit and copy-paste and paste into routers the entire day. Sometimes the templates are generated by another system, but most often it's just search and replace in the text editor. In 2015, I have the pleasure of actually getting to know NSO, because I joined a company that was one of Telia's first customers. And here I've experienced for the first time running an NSO system in production with abstracted business services that just work. And that's a game changer for me. In 2017, I moved to Norway and started at Telia. And very quickly after that, I get thrown into a very, very large brownfield automation project that I get to lead eventually and develop and design services for. And here, it's a good opportunity to reflect on the sort of learnings I've had already here, from the provision button in 2006, all through all the various small solutions we've been able to get through in the business networks. And I find out quickly that my sort of goals for the automation kind of aligns very well with what we've been talking about so far in this conference, that there shouldn't be any manual configuration of the network at all. And we want to design our services in a way where we don't have to think about what vendors or what kind of network elements we are activating it on, what kind of topology they're using. We want our services to be independent of that. And because I've been a network engineer for so many years, I never want to update an Excel spreadsheet with VLANs again. So I want the documentation to come automatically. And we know that now we are developing network abstraction layers. We are doing this with intent-based services, and we are now adding these transport and service separation patterns on top of that. And that allows us to achieve these goals. And because we have a strict separation between our services and our resources in the way that we orchestrate them, we can, with high confidence, create the connections between the services and their resources in order to completely know what resources in the network are owned by what services. So this allows us to build our intent-based services. So in order to understand the problem that I'm addressing today and the solutions that I'm showing you, we need to continue our journey a little bit. We need to understand what came before the intent-based services, which are the more technical-oriented services. And really to start there, I've drawn an example data structure that could resemble a service design prior to going in the intent-based direction. And the important part to notice in this is that we have a technical model that is hierarchical, just like our network, and we are basing our services and relating them to something in the root here, which is, in this example, is a port in the backbone. Here we are relating two services and a CPE to them, and these objects here are full of technical parameters. So we have very little flexibility, and we have absolutely no separation of what is the customer intent and what are just parameters that are necessary to produce these services. Are we changing the transport by either intentionally because we need to move the customer, or are we just rerouting something in the network? We might have to rewrite all these service objects before we can produce the customer again. So we want to move to an intent-based model where we don't have to worry about how we produce that service. So in order to do that, we remodel them as small discrete services. The small discrete services here are independent of each other. They don't relate to any port in the backbone. And we've removed all the parameters that were realization parameters, or sort of the recipe for creating the service in the network. So we are left with much smaller services that here just contain whatever the customer ordered. And we don't have anything that actually points it to a network device. We don't have a CPE host name and a network interface, and we don't have the backbone part of it either. The only thing we have is an abstract identifier called an endpoint ID. And if I was just going to read this intent here, I wouldn't know how to produce this. So we need something more in order to figure out what to build. And the second part of our recipe here is our resource inventory. And this resource inventory is very, very simple, actually, but it contains three important hierarchies here. We have the device list on the top, which is a list of all our devices in our network, not just the devices we manage at NSO, but everything. Also, it can contain stuff that doesn't necessarily map one-to-one with an actual device, because we can cheat and have things abstracted down to be like a device. The second part is the interface link structure, where we can link together two interfaces and two different devices to an identifier, of course. And with that, we can suddenly draw a network diagram of our entire network. The final component is our endpoints. And here we just have an identifier that we point to a network interface. And what does that allow us to? Well, it allows us to completely change the network however we want without having to rewrite the services. And whenever we want to actually effectuate the change, we can go and redeploy our services, and they will be built correctly based on the information we have in our inventory. There's, of course, a lot more to it here, but the principle is enabled by these three tables. So let's bring back the button from 2006. Let's actually click the provision button and see what happens. Normally, I would click that with a mouse, but I have a clicker, so I'll click it. So now we get to the point where we start executing our service logic. And it starts from the top here, and this is a reactive fastmap service, but it could be a nano service. It could maybe even run synchronously, depending on the complexity of it. But we start by figuring out where is our endpoint. Where does this service actually point to? So we read the inventory, we figure out the port, and then we go through the links until we find a device in our network that is capable of producing the service. Because it might be terminating on a CPE, but we need an MP-PE router to produce the service, so we need to find one. We might be able to find multiple, and then we need to figure out which one to use. But we have all this information. We have the inventory with all the links between them, so we are able to do all the routing calculation, all the pathfinding stuff, all the shortest path first stuff. We can make a graph of how to deliver the service, and then when we have that information, we can figure out what else do we need. Do we need some link nets? Do we need some VLANs? Do we need any other things for any of the other technical parameters there? And we can start assembling our shopping list and sending it to Amazon and having it delivered by Amazon Prime the next day. So we sleep and wait for the resources to arrive, and it's not Amazon delivering them. It's probably an external inventory system in most cases, but it could also be the resource allocator function inside of NSO. But as soon as we have all the resources we need, we are ready to actually activate the service, and that's really it. So with this, we have small, discrete, intent-based services that can read external topology information in order to build themselves. However, if that was it, I would probably walk off stage now, but it is not. Because we see some problems here when we are building discrete services that actually have to coexist together, for example, on CPEs. They have to play nice, they have to play together. But they are discrete, so they don't necessarily know about each other. They have common surfaces, and common surfaces can cause conflict. And I'm just going to go through some of the conflicts that we regularly see. The first conflict is about resource ownership. Because we saw earlier that we were going to request resources by our services individually. And if we take this example here, where we have two services on the same CPE, and we also have a transport network in between the CPE and the PE router producing the service, well, we can determine that we need some link nets for the services, but we also need a transport VLAN in the bottom. And really, the resource ownership is easy on the top part of this. Each of the link nets are owned by their respective service, but the transport VLAN is not. The transport VLAN is owned by none of these, or both of these, or all of these. So identifying the ownership of this is a little bit complicated. We need it to be there. We need to ensure that none of the services actually start ordering new transport VLANs because they weren't aware that the other service had one. And we need to also be able to document this and have the ownership be clear in our external documentation systems, right? So we can't just have the owner be a sort of a consequence of there being two services that need it. Another problem here could also be just in the way that we model the intent itself. Because it could be that the service itself was entered by CLI and NSO. Or even worse, it could be that the intent was entered by a customer in a self-service portal. So there could be typing mistakes here. There could be misunderstanding on what do these values actually mean. So we need each service to actually figure out if the intent in that service is in conflict with another service. And that's really hard. And in this example here, we would have ended up writing the same VLAN from two different services to the same port on a CPE, and that doesn't really work. But the VLAN example is actually a very, very good example of this, because VLANs are not necessarily on a per port level, depending on what kind of device you are working with. It could be that the VLAN is global for the whole device that we're working with, or the transport network in front if you're not doing Q&Q, for example. So figuring out with just your layered design in NSO with smart keys and when statements and must statements is not necessarily enough to avoid conflicts like that. We also have a problem when it comes to attribute duplication. So in this example here, we have a customer who calls us and asks for a specific change here, a speed and duplex change on a port. And it so happens to be a port that is used in multiple services. So we have no choice but to configure this in both our services. And 2 services is not a lot, but we have customers with many, many services. So we are forced to duplicate all this information in all the service objects. And we are suddenly tasked with making sure that it's the same and consistent and always updated in all the services. And that's quite a hassle. The chance of somebody making this wrong in one of the services or forgetting it in one of the services is quite high. And then it suddenly becomes a problem in which order you are executing your services. It gets even worse if you think about various product offerings that only exist in some services, but have impact outside of their own service. I'm illustrating this here with a layer 3 VPN, a business VPN service, where you might be able to order a higher MTU because you want to be able to run some storage traffic or some other kind of traffic through the service. And this offering is not possible on an internet service, simply because having a higher MTU isn't really a thing you need on an internet service. But the actual common surface for this attribute spans much more than just what is internal to that one layer 3 VPN service. It actually spans through the uplink port of the CP and the transport network and also the PE port. So what can you do here? Well, you could consider duplicating that attribute anyway to your internet service, but that doesn't really work. Then you're back at the duplication problem again. So that is a really complicated problem to solve. So what we really need is to identify somehow that there is something. There is something common to these services. So what we really need is a parameter to indicate that we have a common surface, that these services need to play nice together in the same playground. And we went out and tried to figure out what kind of parameter we're looking here, and the answer was extremely simple. We have a circuit ID. And it seems stupidly simple, but it wasn't when we designed the small self-contained intent-based services. So we figured out that we need to include a key into the services that identify that they are part of a common surface, and the circuit ID was there for it. I will call it the transport ID for the remainder of this presentation. And we had to define how do we actually identify this? What would it cover? And how do we identify it inside of our NSO models? So we have identified that we have 2 delivery mechanisms. We have the classic CPE-based delivery mechanism, where there are certain rules for where can we deliver services on. If it's a CPE, you can deliver it on all CPE ports. But we also have other kinds of services where you're, for example, delivering in a data center or delivering to a customer that that has their own CPE or through a third-party provider or something like that. And in both cases, we need to identify these transport differently. In the CPE one, we identify it with the ID of the link that connects the CPE to whatever it is that they're meeting first in their network. And in the CPE-less one, we identified specifically with the endpoint that the services will terminate on. And in addition to just identifying how we figure these transport parameters out, we built 3 components together here. In the top, we have our regular business services, our internet services, our L3 VPN services, layer 2 VPN, VPLS, whatever. We have a lot of services, and these are then given a new parameter for identifying the transport. Supporting all this, we have a new service which just defines the transport. It's a service in its own, but it doesn't configure anything in the network. It just holds these common service parameters and provides some API for the services to work with this. In the bottom, we have a service registry. And this service registry allows the services to register their parameters, and it helps keeping these conflict-free. And we found out immediately, just by adding the transport parameter to the service, we now have a very easy way to solve some of the problems that we described previously. We now have another identifier that we can use whenever we book a resource that needs to be owned by all the other services commonly. And we also found out that it's not a problem if we have multiple of these. I mean, you can have a CPE with multiple uplinks, that exists, and really it's the same exercise. We now have 2 common surfaces, but the mechanism where we provide or where we register and resolve the conflicts is the same. So what we generally do is we have this transport registry in the bottom where each of the services register the parameters to, and we have an API that allows us to resolve these parameters and return something back to the services. And this transport registry is basically just an Excel spreadsheet inside of NSO, where each of the service will register a line, a row per transport. And then we resolve all the parameters with rules per column. So for example, in the MTU example, we are now able to look at all the MTUs and figure, well, it doesn't matter that these values are different. That's not a conflict. We just need to make sure that the services receive the highest value back so we don't cause any conflicts and we don't override the network with incorrect values or cause MTU issues. Similarly, we can figure out whether the different interfaces are allowed. If it's a CPE, they would be, as long as the CPE hostname is the same. And should we deviate on the CPE hostname by somebody entering the wrong endpoint ID into a service, we would immediately notify our service that there is a conflict here. So how does it solve it? Does it solve it? We identified the 4 challenges we had with the resource ownership, the conflict in the intent, and the attribute duplication, and the inherited stuff. And yes, just the ownership is solved by just having a new ID. We can register common things under. And we have a conflict resolution mechanism that can now validate services across, or validate parameters across services. We also have a new service where we can register these parameters that to avoid duplicating them around the different services. And we can use this API here in the last example to return the conflict-free parameters back to the services so we can solve things like this MTU issue. So the components we created in order to solve this were, as I mentioned before, the CFS entity and the internal registry, and most importantly, the Python API to work with these transport parameters. We've also created some user actions that help to work with this in a good way. So actions to perform bulk updates, but also actions to allow conflicts. And wait a minute, allow conflicts? Well, when you're creating a conflict resolution mechanism like this, you're essentially locking the service is down. So what if you actually need to change some of these parameters and cause conflicts? Well, you need to have a mechanism to actually allow the conflicts to happen again. And we built that in and built in a mechanism that actually allowed us to automatically unwhitelist them again as soon as they had converged again. Because no matter what you do, if you have 4 services, even though you change all the parameters at the same time, the service points are still executed in order, and you still have conflicts as soon as you get to service number 2 in the stack. In the service registry, we have a post-modification hook that basically just iterates over all the services that are whitelisted and checks whether they're still in conflict. If they're not in conflict anymore, they're removed from the whitelisting. And in the services themselves, the services register themselves with a data class instance that contain all the parameters that are relevant from the service point of view. They give that to a common class in the middle that then returns an object back, which is sort of the resolved parameters, including the MTUs and any other value we need to make sure that we are inheriting across services. So this is something we added onto our services. This wasn't something that we designed from the beginning. And so we started with a replication model. So we started by just duplicating all the parameters from the service that we knew were not just relevant to the single service, but had this impact above itself. And we just copied them down to a transport service. And then we created an action that would copy them back again to the service. And then we told the users that they shouldn't change it on the service anymore, they should change it on the transport instead. And that allowed us then to eventually start disabling functionality in the service. And but we still went from a model where we didn't need to create the transport service in order to create new services. It was still an optional component. But the goal that we are then slowly moving to is a model where we have none of these parameters left on the service, and we have a transport service that can be read from. So we don't need to push parameters back to the service. We can just resolve them from the service itself. But that makes the transport service an initial requirement before we can add any services. And that is a change that is a little bit hard to do. So if I'm to sum up some of these things here, we've seen when we do these self-contained intent models that there is, it's not a problem if they are completely isolated, but as long as they work together with shared resources, there are a potential for conflicts. And changing things with many services that inherit these common surfaces is complicated. We've also seen that it's not that hard to find a good parameter to actually identify these common surfaces. And we've also seen that just checking that there is a conflict is not enough. We need to be able to resolve all these parameters individually. And that's because all of these parameters have their own rules. Sometimes it's okay that there are different values from the services, but it really depends on what parameter it is. We also know that this conflict resolution has the potential to locking the services in place. And we want to have tooling and methodology around that to make it smooth and easy for the operators to actually do the big migrations of the customers without ending up in a situation where NSO just says no. So with this, we can hopefully say that we didn't peak in 2006. We have a potential to get back to having an intent-based model where we can just click the provision button or have that being clicked automatically. But there's a lot of consideration that goes into it. Our experience with implementing this is that it's very easy to just add the first initial part. It's very easy to augment a model with a transport ID and the conflict resolution. Well, it wasn't a very quick thing to write, but it's definitely possible to add it without too many problems. But what actually is the complicated part is to move the parameters away from the service, because you gotta have that right. And you are modifying the service quite a lot. And this whole thing about just copying the fields over and copying the values over and then removing the functionality, that's a good step one. But eventually you also need to deprecate the leaves in the Yang model, and you need to eventually just remove them entirely from the Yang model, and that is not a trivial thing to do. We found that you had to do a lot more of the changes inside of Python, because you want to be able to do this synchronously. You don't want to have this as a reactive step. You need to resolve the conflict right at the moment. And I have to say, I have not tested this with the changes for NSO 6.1. I have a good feeling that I'll need to rewrite quite a lot of this when NSO 6.1 goes out with the changes to how services are processed. But we'll see. I still work in a place where we have highly skilled engineers who copy and paste stuff, but they copy paste stuff into NSO these days, and I guess that is some improvement. And with that, it's the end of my presentation.
Very good, thank you very much, Alan. I can remind everybody about Slido. We have the Q&A tab open, so if you want to post questions, you're welcome to do so. In the meantime, let me ask you a question from my side. Mm-hmm. So you obviously spent quite of effort, into thinking about how to abstract services and how to model your service intent, and how you break that down into kind of a hierarchical view of the different resources that you have in your network. How did you arrive to the point where you are today? I mean, what was that? Was that an iterative process where you tried lots of different approaches and then finally kind of found your way there, or was it something that you came to intuitively and found as a kind of a natural way of doing it?
Well, I wish I could say that it was easy. It hasn't been. It's something that we had to have a bit of trial and error with. We've had a lot of design patterns in how we design our services that we've revised over the years. I think that the central principles were there from the beginning. We wanted to have this intent-based approach. We wanted to have our small self-contained services. That principle was there from the beginning, but figuring out what are the limitations and how do we adapt around that, and also how do we design our services in a way where it's intuitive for the users and the APIs to use them. That has not been easy, and I don't think we're 100% there yet. It's still something that we're reworking once in a while.
All right. Another question from my side. So I know you have operations in multiple countries and probably have different silos and networks and legacy to deal with in the different networks. The way you have abstracted your services, is that going to make it easier to kind of reuse what you've built in multiple countries? And the follow-on question to that is, are you finding alignment within within Telia across the different organizations to kind of adopt the work that you've built in Norway, and how do you collaborate with your peers in other countries around that?
Yeah, we have a lot of focus on building common services, and we are finding that the commonality lies different places. We can align on the service models. And we hope to be able to be completely aligned here. But we're also seeing that countries have different ways of doing things. They have different requirements as well. So we have to be a little bit flexible in our service models. It's not something where we are exactly where we want to be yet. But we're seeing more adoption on common services, and as they're rolling out, because we're also doing network upgrades at the moment, and that's a very good time to introduce common service models into it.
Okay, very good. Do we have any questions from the audience? Anybody? Anybody who has a different experience, modeling your services and the infrastructure? All right, then I think that's it. Thank you very much.